In this lesson, we're going to be solving systems of equations by graphing. So to solve an equation with one variable, you only need one equation. If you have an equation with two variables, then you're going to need two equations to solve for both variables. And so forth. If you have three variables in your equation, you're going to need three equations to solve that system. So one method for solving the systems of equations is graphing. So to solve the system of equations by graphing, you're going to first put the equation in a format that allows you to graph it, like slope-intercept form. Once you identify the slope and the y-intercept, you can use those to graph the line. And then once you have both lines graphed, the point where the lines intersect is the solution of your system. Now it's important to understand the different categorizations for systems. If the two lines intersect at exactly one point, the system is said to be consistent and independent. If the two lines intersect at all the same points, meaning they're the same line, one line is right on top of the other, then we say that the system is consistent and dependent. And if the two lines are parallel, meaning they will never intersect, we say that the system is inconsistent. All right, example one. So we have two linear equations already written in slope-intercept form. So we identify the slope and the y-intercept for both lines. The first line, the y-intercept is 3, so we put a dot at 3 on the y-axis. And the slope is 1 over 2, so from that y-intercept we're going to go up 1 and over 2, graph our next point, draw a line between the two, and then we do the same thing for the second line. The y-intercept is -2. The slope is 3, so from that y-intercept we're going to go up 3 and over 1, draw a line through those 2 points, and the point where those two lines intersect is our solution. The coordinate for that point is 2, 4. Next example. Now we have two more linear equations. However, we need to put both of them in slope-intercept form. So for the first equation, first thing we want to do is add 5y to both sides and then divide both sides by 5. That's going to give us y equals -2 over 5x minus 5. And then we want to put the second equation in slope-intercept form. We do that by first adding 10 to both sides. And then we're going to divide both sides by 10. And in slope-intercept form, that equation is y equals 4 over 5x plus 1. So we first graph the red line, the top line, which has a y-intercept of -5. Slope is -2 over 5, so from there we're going to go down 2 and over 5. Draw a line through the 2 points. For the second line, the y-intercept is 1, so we should have a dot at 1 on the y-axis. And the slope is 4 over 5, so from that point we're going to go up 4 units and over 5 units. Draw a line through the 2 points, and we're looking for the intersection of those two lines. That intersection of the two lines is right there. The coordinate for that intersection point is -5, -3. All right, next example, both lines are already written in slope-intercept form. So the y-intercept of the first line is +6, so that's our first point. The slope for that line is -1 over 4, so from the y-intercept we're going to go down 1 and to the right 4. Graph our next point, draw a line through those 2 points. Do the same thing for the second line. Y-intercept is -3, so our first point is at -3 on the y-axis. The slope is -1 over 4, so from that point we want to go down 1 and to the right 4. Draw a line through those 2 points, and as we can see, in the graph that the lines appear to be parallel, and we can verify that by looking at both of the equations. Both the equations have a slope of -1/4. Since they have the same slope, the two lines will never intersect, and therefore there is no solution. In the last example, we need to put both of these equations in slope-intercept form. First thing we want to do to get the first equation in slope-intercept form is add 15 to both sides, and then we're going to divide both sides by -5. When we do, we'll get y equals 2/5x minus 3. And then we want to put the second equation in slope-intercept form by, first thing we want to do is, looks like I just rewrote the equation so that 5y is on the left side and the 2x minus 15 is on the right side. Divide both sides by 5, and we get y equals 2/5x minus 3. Y-intercept is -3. The slope is 2/5. So from that point, as you can see in both the equations, they have the same y-intercept, they have the same slope. So both of the lines are the same line. So since they are the same line, there's going to be an infinite number of solutions. There's infinite solutions since this system is consistent and dependent, meaning that both the lines are right on top of each other.